Hello everybody, today we're gonna discuss about simple linear regression, how we will do simple linear regression in different plots by adding p-value, r-square value, and finally we will do different simple linear regression plot, and we will compile the number of plots in one sheet or in one plot. So in order to do that, the two packages are mandatory. The first one is the ggpebble and the second one is the ggplot2. So my data here is the raw data. I will import from my working directory, which is in the form of CSV, and it's found. The name is raw, so raw data CSV. Then I will import in this way. Then after, you can assign any name that you want here, and you have to use a function, the gscatter, and you have to indicate your data name. So in our case, my data name here is raw data, and x comma followed by y. So x means the independent variable. For example, for in this case, in our case is pt is a productive tiller, which is independent variable, and the y-axis is represented by gy. Gy means it is the dependent variable. So followed by add is equals to regression line. So you will draw, or you will get a line, or you will get a regression line, plus you have to use a function stat core in order to get the correlation value. So in the x-axis you can indicate, for example, label.x means at what position should the correlation value displayed. For example, I said here is 80, and in similar fashion the label y indicate that at what position in the y-axis should the correlation value displayed. I here indicate in the 5.1, so the r-square value in the x-axis at 80 point, and in the y-axis at 5.1, it will be displayed in this form. And then again, you also indicate r value means, which is the r-square value, and again here is the p level means the probability level, or the p value. Then you can also use this syntax. Then you have to uh, draw, or you have to indicate the regression line equation. That means if it is simple, it will be y is equals to a plus bx. So that, and again, at what position should this regression equation should be follow, should be indicated. I here is around 80, and again, at what level should be the regression equation displayed. In our case, the correlation value is displayed at around 5.1, but I here suggest 5.5. That means the regression equation, the regression line equation is above from what? From the correlation. So I will indicate in this manner, and also size is equals to 4 or 3, 2. You can assign any name, any number that you want for displaying. For example, if it is 3, so the equation size will be reduced. If it is 2, again it's reduced. Or if it's 5, it is very become large. So doing this way, and again, let's run this all together. And again, as I mentioned before, we will draw a number of plots, then finally we will combine those plots in one form, so that OP is what we created. All this equation is represented by OP plus the GG title. I suggest here is A plus the lab, that means the x-axis as well as the y-axis. So x-axis is PT in short form, so I write here is in the full form, which is productive tillers, and y-axis is represented here is GY, so in the short form, so I write here is grain yield in kilogram. So I do in this way. So type this and submit to our studio. Then finally, let's see our result. Yes. So this equation is around 80, and the y value is around 5.5. Let's say around 50 and around 3 point something. So what will happen? We will see together. Let's type this 50, let's type this 3.1 as it is, and let's type this 3.5, and again let's type this 50. So run all together. Let's see the value. Yeah, as you see, so it is around the equation is displayed around and the x-axis around 50 point, and here is the 3.5 is the regression equation, and the 3.1 is the r square as well as the p value. Even you can shift this r square value above the regression equation. How to do? You have to change here is 3.1, yeah, so instead make it 3.5 and change this 3.1. So we will expect what? We will expect the p-value as well as the r square value is above the regression equation. Yes, yes. So in this way you can arrange your uh, r square value as well as the uh, regression line equation. So let's back to the original one. Yeah. So let's type this and run. So do in the similar fashion for the rest parameters. And my second parameter here is the TT, which stands for total tiller, and GY is for the grain yield. So do this one in similar way and submit to our studio. So I'll show you how to compile different plots in one form. And again, for the third one, also do in similar fashion. The thing that is changed is here is NK, that means number of seeds per spike. So it is very easy. I hope it's very easy for you. And again, do for the other. So we'll do 6 simple linear regression plots, and we will compile all those one into one uh, one form. So here is a planted. So as you see here is I changed it to pH, and also the title is E. That means we did 5 plots. Then lastly, let's do the 6, which is SL, stands for the spike length, and all things are the same. So run this, submit to our studio. Then let's compile. In order to compile the plot, the patchwork is mandatory. So type the patchwork library and write to run to our studio. Then we can assign here, we can assign any names that you want. I assign here is Waka. Waka means D0 slash D01, and again you have to use here is vertical bar, here is slash, and again D02 vertical bar, D03 slash D04 and DO05. So if you type this, you will get uh, six uh, six simple linear regression plots in one form. DO5 means what we created for what? DO5 is for spike length. Spike length simple linear regression for spike length. DO4 means it is for the planted. And again, DO3 means it is for what? The 1000 kernel weight, what we assign here. And again, DO2 means it is what we assign here for the number of seeds per spike. And DO1 here is for total tiller, and the DO0 means which is for what? For a productive tiller. So we will combine all these in one single plot. Let's show you what Waka look like, or what our all the 6 simple linear regression plots compiled form is look like in this way. Somehow it is messy, but it's very noisy. But I suggest you to do this function, to use this function. That means the ggsave, and you have to indicate the file name. For example, let's say LA. You can assign whatever you want, and la.png is the format. Then the plot that means which equals to waka. Waka means it is the combination of what? Do vertical bar do1 and slash. So that means do vertical slash do1 means it will display the two graph. That means do and do1 will be displayed in one form, and again two graph will be displayed at the same time. Two graph will be displayed at the same time. That means horizontally. So side by side, the DO as well as the DO1 will be displayed side by side. And again, here is DO2 and DO3 will be displayed side by side. DO4 and DO5 will be side by side. But the slash here will separate into different components. So this will be in the top side by side, and again this will be in the middle side by side, and this will be in the last side by side. You will do in similar way, and you will get six plots in one form. But this is somehow the width as well as the height is not appropriate. In order to get an excellent plot, you have to assign any name that you want here, and the plot is equals to waka means what you created here, and the width which equals to 20, and the height which equals to 25, and we can use the DPI or the increase the pixel quality, 2500, and the unit is centimeter. So if you type this and submit to our studio, you will get an excellent uh, image. So our name is LA, so we'll go to our working directory and we'll find the LA in the form of PNG format. I'll show you it is in the progress. So I'll show you how it is look like. Still it is working top. Then here is the GU. Then the name is LA. Yeah. So here is the image. Sorry, opening it. Yeah. Yes. Yeah. So in this way, we can customize the simple linear regression plots by compiling for a different number of variables. So yeah, so see it is a very it have very good uh, quality. So in this way, we can conduct our simple linear regression plots for different variables and compiling all of them in one way. So if you have any questions, appreciations, you can address me through a YouTube comment box, or alternatively, you can use this email address. And I have received a number of questions, so I will address those questions in a point by point fashion. Thank you for your patience, and please wait the upcoming videos in order to get your answers. So stay tuned, stay blessed, and have a nice time.